So probability 3, we're going to start off with some keywords: trial, outcome, sample space, and an event. Put these keywords and definitions into your copy. A trial is the act of doing an experiment probability. An outcome is one of the possible results of the trial. A sample space is the list of all possible outcomes in a trial. And an event is the occurrence of one or more specific outcomes. Some revision on the probability scale. You guys should have seen this before. Take these notes into your copy. 0, 1, 0.5. 0, as you all know, is impossible. Something that's impossible to happen. Coronavirus will disappear tomorrow is impossible unless this is 12 months in advance. 1 is certain. 0.5 is like a 50% chance. Well, the most obvious. So 0.5, 50%. So coin flip. Let's look real quick at 25%. What would have a 25% happening? Well, if I flip a coin twice, and coin flips and cards are two of the most commonly used things in probability, I can get a head or a tail. So if I get a head the first time, I can get a head or a tail the second time. This is like a tree diagram from before, and I can get a head or a tail the second time. So if I list all the possible outcomes here, I could do a sample space. My outcomes are head, head, which is this one here. I also have head, tail. I have tail, head. And I have tail, tail. So the probability of tail, tail is 1/4, which is 25%. What's the probability of not getting two tails? Well, that's the subtraction method. It's 1 minus the probability of two tails, which will be 75%. So take that down as a quick diagram in your copies, and maybe do a tree diagram with 3 coin flips. So you've listened to what I said and done your 3 coin flips. So what are the outcomes here? Let's list these sample spaces. Head, head, head. That's the first one. Head, 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 tail. Then we have these 3 down to here. Head, tail, head. Then we're down to head, tail, tail. Then we're down to the 4 that begin with T. THH. THT. TTH. And TTT. It's good maths to practice drawing these out, understanding the outcome. There's 1/8 chance of getting 3 heads. There's 1/8 chance of getting 3 tails. There's a 6/8 chance of not getting 3 heads or 3 tails. So what have they got? We have 2 heads and a tail, 2 heads and a tail, and 2 heads and a tail. So there's a 3/8 chance of 2 heads and 1 tail in any order. And if you look, there's 3 left, and they're all going to have 2 heads, or 1 head and 2 tails. So there's a 3/8 chance of getting 2 tails and 1 head. Make sure you have this in your copies. So I've introduced this just previously. Experimental probability. Relative frequency is what we're going to call it. It's the same thing. So relative frequency is the number of times, or the frequency of an event over, and you've seen this with the heads and tails, over the total number of trials. So I've introduced the maths first. This is the formula, or the word-based formula. Harder to remember this, I think, than just doing the maths yourself. Okay, so how are these questions asked? Relative frequency. So this is the probability when all outcomes are equally likely. So a fair, this is what they'll describe in the questions in exams, a fair dice, which means all outcomes are equally likely. And what's the probability of getting greater than a 4? And you guys are shouting, well, how many outcomes are there greater than a 4? 2. Out of the total possible number of outcomes, 6. So you have a third of a chance, 1 in 3 chance, or a 33% chance of getting greater than a 4. And then they may ask if the dice is rolled 100 times, or if the dice is rolled the number that divides by 3 120 times. The probability of greater than 4, or how many times it's likely to happen, will be 120 by 1 over 3, which is, you'd expect it to happen 40 times. So this is the expected frequency of something happening. Okay, so write these notes into your copy. We're dealing with cards. There's 4 suits. 2 are red, diamonds and hearts. 2 are black, clubs and spades. Each suit has 13 cards. If we multiply that by 4, we're going to get the number of cards in a deck, 52 cards. We never include jokers in these questions. There's 4 picture cards. You do need to know that. If you don't know there's 4 picture cards in a deck, just think ace, king, jack, queen, or queen, jack. And then there's 9 number cards. There's no number 1. So we go from 10 to 2 for the number cards. So the questions that could be asked, the probability of getting a jack. So the total number of jacks, 4. The number of outcomes, 52. You don't get extra marks for simplifying on probability. So you can leave it as 4 over 52. You could write 1 over 13 if you wish. But I'm going to leave it at 4 over 52. What about the probability of spades, or a spade? Well, how many are there? 13 over 52. So you can see it's a 1 in 4 chance, the amount of suits. What about a red card? The probability of a red card. These are all just basic probability questions. But probability, when you know how to do it, is basic. There's 26 of them out of a total of 52. What about the probability of a spade or a jack? Now be careful here. One of the jacks is a spade. So there's a crossover here. So there's 13 spades and 4 jacks, which is 17, but one of the cards is doubled up. So there'd be 16 chances out of 52. So practice some of these questions from your book, and we'll move on to probability theory in the next lesson.